Hi, in this video we're going to try to understand this first equation in more detail. We have given a ratings of player A and a rating of player B. What is the expected probability of winning for player A? And we'll look at this scale factor of 400 and the base 10, how they affect probabilities. And so we're going to use this online graphing calculator tool called Desmos, which is pretty cool. We have equations and variables on the left, and they're plotted on the right. You can see we have a red, or two distributions or functions. I have a red one, which represents player 1, and a purple, which represents player 2. And I've just drawn two vertical lines just to make it easier to visualize the center point of these distributions. And you see I can slide and control the average of player 1's skill, and we'll see how that affects the expected outcome. So we have this D right here, which is the difference between player 1 and player 2. You see if player 1 is really far apart then from player 2, we go from 1300 right here, then they have a really low chance of winning. This is only 3% of winning. But the closer they get to player 2, if you put them right on top of each other, it's exactly 0.5, which is what we expect. Neither one of them has a chance of winning. But if we say, okay, what if player 2 is worse? We see the probabilities are now switched, and now player 1 has a high chance of winning because player 2 is worse, and player 2 only has a 2% chance. And so this is how the subtraction, when you go back to the algorithms here, the rating of player A minus the rating of player B is affecting that probability. And we can see because these are probabilities, they add to 1 because it's a zero-sum game where the probability of the other one is 1 minus the other person. And then let's also explain this scale factor here. So I think a lot of this you see probably on this page, just more details about this S. Let's see, where's the scale factor? Yes, scale parameter here. It basically controls how the standard deviation for how wide this distribution is. And you can see if we slide this here, it controls the peaks. And this, in practical terms, means when a player competes, how likely the other to play at a different skill level. If it's very narrow. Let me separate these just a little bit so you can see. It's very unlikely for a player that's only, let's see, where's the difference? Only 1,300 points less to ever win. But if you increase this wide enough, you'll see that the probability is down here is adjusting. And we've made it a little bit more likely that they can win because player 2 could now have a higher chance of playing at a lesser level. So you see as I change this, it's kind of hard because they're on different sides of the screen, but this probability is changing as I drag this slider. So you see it goes really low, and then if I drag it up, it increases. Not a lot, but just enough. And I'm not sure of the history of the algorithm in chess, but it seems like they determined that the scale factor of 400 and they're learning about this other parameter called k, and 32 was a good adjustment for peoples in different ranges. And we'll look at the k factor in the next video. Thanks.